Kia ora, and welcome to Safety Unplugged podcast, where we explore the latest in industrial safety, control systems, and risk management. Whether you are an engineer, safety professional, or simply curious about how we keep complex operations safe, this is your space. Today's episode dive deep into powerful risk assessment method used in control systems, CHAZOP or Control HAZOP. This is an essential process in the life cycle of safety and automation systems, and yet many still find it mysterious and overlooked. So, let's get into what CHAZOP is, when and why it is used, and how to practically conduct one, including a full step-by-step breakdown with real lifestyle example. CHAZOP stands for Control Hazard and Operability Study. It is a structured and systematic examination of control systems and their interaction with human operators. It is similar in structure to a traditional HAZOP study, which focuses on process deviations, but CHAZOP focuses instead on the integrity and reliability of control and automation systems. It is particularly important when dealing with the programmable logical controllers, distributed control systems, human-machine interfaces, and safety instrumented systems. CHAZOP helps to identify potential failures or design weaknesses in these systems that could lead to hazardous situation or operational disturbances. So, if you are familiar with IEC 61511, the international standard for functional safety in the process industry, you will know it outlines a full safety lifecycle. CHAZOP typically fits within the detailed design and validation phase of the lifecycle, which means after process HAZOPs are complete, when the control strategy and the safety systems are defined. Before the final commissioning, which means allowing time to make necessary changes or upgrades, and as a part of the periodic reviews, especially if modification or changes have been made to control systems. Now, why CHAZOP is important? Because in today's facilities, control systems are often the first line of defense. If a controller misbehave, an alarm floods the screen, or the HMI shows misleading information, the operator could take a wrong action or fail to act, leading to a hazard. This becomes even more critical in high automated plants with limited human oversight. CHAZOP helps uncover those issues that our traditional HAZOP might miss. To illustrate the importance of the HAZOP, let's examine two real-world examples from Australia. In October 2013, a fuel tanker operated by Coots Transport lost control on Moona Vale Road in Sydney's northern beaches, overturned, and collided with multiple vehicles. The tanker ignited upon impact, resulting in the tragic death of two individuals and injuries to five others. The accident also caused extensive property damage and environmental contamination due to the spillage of thousands of liters of fuel. Investigations revealed significant mechanical issues with the tanker, including faulty brakes and suspension systems. A subsequent audit uncovered nearly 600 defects in the company's fleet, many of which were major safety concerns. This incident underscores the catastrophic potential when the system hazards are not thoroughly analyzed and mitigated. Conversely, the Oban City Access Project in Adelaide serves a testament to the benefits of conducting a CHAZOP. This project involved constructing a 670 meters tunnel to improve public transport efficiency. Recognizing the complexity and safety critical nature of the tunnel's control systems, the project team conducted a CHAZOP study. This analysis identified potential control system hazards, allowing the team to implement safeguards proactively. The result was successful project completion with enhanced safety and reliability for daily commuters. So before I jump into the key steps to conducting a CHAZOP, I think it would be beneficial if we discuss the phases of CHAZOP. So, like any other study, preparation is the key to success. In CHAZOP, we also required some preparation. The first thing is to identify the boundaries and scope and objectives. Also, we can identify the key concerns and expected outcomes. In this phase, we do gather all the necessary documentation like PNIDs, functional descriptions, and failure records. We also gather team includes control engineers, safety personnel, IT experts, and operators, and as well as um, cybersecurity engineer as and when required. In the next step, we do node by node analysis and we systematically assess each functional areas for risk and failure points. Once analysis is complete, we perform the documentation part where we capture all the risk, propose mitigation, and prioritize the corrective actions. In the last phase, which is implementation and follow up, we assign action owners, monitor progress, and schedule a follow up reviews. So the key documents required for the CHAZOP are PNIDs, cause and effects, control system architecture, system functional description, alarm rationalization reports, software and hardware design specifications, which is very, very, very important. Um, then cybersecurity assessments, if it is done, and any historical incidents and maintenance records if we are doing the brownfield projects. Also, we need operator feedback and known control issues. This has always been in a consideration that who needs to participate in the workshop. We always try to gather as much as people, like, from many disciplines. It is always a debate that who needs to attend the CHAZOP and how to develop a team. So I think there are a couple of people who are really required. The CHAZOP facilitator, the first one, which is definitely required, who will run through all the CHAZOP. He should have a control system expert and very good understanding of hardware and software. Process engineer, yes, and control and instrumentation engineer, yes. Then operations representatives, yes, who should know the in and outs of the process and operations. Safety engineer, IT cybersecurity expert, yes. If we are conducting a cybersecurity part in it, then definitely we need a cybersecurity engineer. Maintenance engineer, yeah, sometime it is required, sometime not, but it depends on the case to case basis. The project engineers for new projects, yes, who knows that who are the stakeholders. Then if there is a vendor requirements, like for example, if you're developing a new control systems and conducting a CHAZOP for the new one, then I strongly recommend to have a vendor representative in it. So during the workshop, we define the nodes and we discuss all these nodes systematically. Um, let's say DCS and SCADA system can be a one node. Then PLC based control systems, HMIs, alarm management system, or field instrumentation. These are some examples of the nodes, and there for each node there is an action and the recommendation. For example, in the DCS and SCADA system, if you have frequent communication loss between operator station and the controller, then there must be an action for it. And the action and recommendation can be the upgrade of network infrastructure or implement redundant communication pathways For field instrumentation, for example, there is a level sensor which is giving a false value. And so, what we can do as an action, we can implement a regular calibration schedule and diagnostics. Once we define the nodes, we need to define the guide words and the type of the deviation. Like for each node, we can have a different guide words. For example, loss, range, mixture, version, security, and these all depends on the node type. Let's say loss of signal. Let's say so we can have a no power, no communication, memory corrupted. So it's a loss. However, in the security, we have a different type of deviation like abnormal behavior or loss of functionality. We can also have a breach of trust or breach of confidentiality. Let's walk through an actual CHAZOP exercise. We will use a simple level control loop with an operator interface. Imagine a water tank level control system with a level transmitter, a controller, a control valve, and an HMI. Starting with LT101, the guide word no input implies the controller is receiving no signal. This could be due to the transmitter fault or a broken cable. So, what would be the impact? The controller won't know the tank level and might fail to control the valve, causing overflow and a dry run. While existing safeguards include an alarm and the ability to check manually, we recommended adding diagnostics to the transmitter and configuring an automatic fallback mode to prevent this. Next is LIC 101, the controller. The guide word here is wrong output, which results in incorrect signal going to the control valve. A likely cause is misconfiguration or a logic error. This could make the valve behave erratically, which means opening and closing when it should not. Though manual mode and backup option exists, a robust solution would need to be validate logic through simulation testing. For the HMI display, the concern is misleading display. This happens when the operator sees incorrect level due to bugs, outdated data, or communication issues. The danger lies in the operator making decisions based on false information. Safeguards include trend data and redundant displays. Still, we should consider adding time stamps to the data and redesigning the interface for better clarity. Finally, alarm management is vulnerable to alarm flood. This occurs when too many alarms activate in the short time. Poor alarm prioritization or signal noise is typical at fault, which results in operator overload. While there are tools like alarm shelving and first out logic in place, the system would benefit from full alarm rationalization based on IEC 18.2. Each of these examples shows how CHAZOP help identifying both technical and human factor vulnerabilities. CHAZOPs are only as good as the preparation and the participation. There are some common challenges and you can avoid them if you just follow the guidelines. So, the main problem which is I have observed in lots of CHAZOP is the lack of the clear scope. So, how to tackle it? You just define what systems are in and out of the review. We can simply avoid this. And, you know, you need to also include operators, not just an engineer. So if you have insufficient team diversity, then there is another problem. Also, hardware and human machine interface are equally critical, So you don't need to just to focus on the software part. And you also need to just see you have all the documents ready, like PNIDs, logic diagrams, and alarm list, and just ensure that there is no missing documents. Also, the skill facilitator keeps the discussion moving in focus. So the poor facilitation is another issue. So if you follow all these steps or guidelines, you can clearly avoid mistakes. So a well-run CHAZO doesn't just tick box. It finds those what-if scenarios that are not covered anywhere else, especially in the modern, the complex systems. CHAZOP might not be widely known as HAZOP, but it is critical tool in ensuring control system integrity. In safety critical industries, overlooking the control system side of things can result in incidents even if the process design is sound. Make CHAZOP as a part of your project lifecycle, not an afterthought. If your facility or project is planning to implement or review safety systems and you need help conducting a CHAZOP, we are here to support. Reach out and let's talk about how to make your system more resilient, safe, and operator friendly. Thank you for tuning into Safety Unplugged. If you found today's episode helpful, be sure to subscribe, share it with your team, and check out our other episodes on functional safety, alarm management, and cybersecurity. Until next time, stay safe, stay smart.